You pay attention. With so much at stake.
Seas are rising and chronic flooding will be the new normal.
You navigate, you listen, you keep an ear out. You pay attention, and so do we. We tell the stories of our time every day.
In the 26th day of testimony and on the 139th witness, Shahar Tsarnaev wept.
We unearth what would otherwise stay hidden.
There's just a lot of hate in this world, and that day, for that hour, we were humans.
Across the street.
The Red Sox have won the World Series.
And around the globe.
It's here and now.
This is
Modern Love.
This is WBUR's All Things Considered.
This is only a game.
This is On Point.
This is Radio Boston.
On air, online, on demand, and on stage in the heart of Boston.
I'm Jack Lepiars. Welcome to WBUR City Space.
Always looking forward, paying attention, and knowing that your story is one of our stories.
Good morning. I'm Bob Oates.
I'm Lisa Mullins.
I'm Meghna Chakrabarti.
I'm Jeremy Hobson.
This is 90.9 WBUR Boston.
All right, here we are. This magic iPad thing. All right. Right. Oh, sorry. Jeez. All right. This is Leila Hatch, so on the film. All right. First question. Right. Did you get to meet Sting? No. Make sure you hold us here because everybody wants to hear
I
you.
didn't get to meet.
Okay. So we wanted, this is Leila Hatch, who you saw in the film, who works at Stellwagen Bank for NOAA. I wanted to first start off by just having you tell a little bit about what you do. And we have a map of Stellwagen Bank to show people in case they're not familiar where it is.
Yeah.
Can we?
This is our backyard.
Yeah. Ta-da! All right. I'm going to get out of the way here. So can you just tell people a little bit about where this is and what you do?
This place. We are here. This is us. And this is the majority of Massachusetts Bay. And you know where you are by the landmarks, I'm sure, but these are your sea marks. Stellwagen Bank National Marine Sanctuary, which is one of 14 places across the U.S. that we protect as designated sites that the federal government works for you to ensure, to prevent injury to, and to keep them ecologically functioning for the specialness of what they are. Ours is the majority of what are the federal waters, the waters outside of state waters of Massachusetts Bay. And the central feature of this place is Stellwagen Bank, which is an underwater hill, really, an underwater rise that is made up mostly of sand and gravel. And there are maps with fish imprints that go back over centuries, marking this place as where to go if you want fish, right? Places, this has been a known fishing ground for a very long time, and not only by us, but by whales. So most of the populations of endangered whale species in the Atlantic come here predictably to feed in the spring. And so this place was protected from the kinds of things that other kinds of needs we have offshore. In 1992, it was designated as a place that we would manage as a protected National Marine Sanctuary.
Right, thanks. All right. And I know most of that film was about whales, and everybody loves to talk about whales, but I want to talk to you about haddock.
Yeah.
Because you study the effects of sound, not just on whales, but on fish.
Correct.
Right? And which is weird because I feel like I don't even know if fish have ears or they hear, but I wanted to play, you sent me these wonderful sounds that fish make, and I wanted to play one and we could talk about this. Can we have the haddock? The sound of the haddock.
Someone's knocking at your door.
That was cool, right? I mean, sorry, what is that haddock saying?
The haddock, we know that they make those sounds during lots of different kinds of competitive interactions between individual fish, but there's a time period.
Wait. What does that mean? Competitive interactions between the haddock?
Well, in general, fish in, well, we can study fish in two ways, right? We can nicely, and this is very different from the rest of the film we just watched, we can bring them into a tank and watch them. And in that kind of situation, you can have antagonistic behaviors among critters. They're in a smaller space. You can watch sorting, and especially during reproductive time. So if you have a time when males are gaining access to females and that kind of dynamic is set up, then you can hear this in a sort of antagonistic way. But the main time that you hear this in a wild scenario, when there's wild open ocean scenario, is during spawning. So this is part of what triggers fish to know that females are ripe and that the males come together, and there are larger congregations that can be found acoustically. So they're not only interacting with each other over a really small scale, but that's actually a relatively lower frequency sound. Frequencies are one of the ways we characterize sounds, right? And they are down here, very low tones, or up here, very high tones. Those are different frequencies. And these fish are vocalizing at lower frequencies. When you do that, you can hear yourself over a larger distance because those sound waves travel farther.
Have you found all the sort of different fish in the sanctuary make sounds, or only a couple? Is that rare or is that common?
No, it's common. There's pretty much no location in the sanctuary where we put a recorder down where we don't hear fish. So that is not, every place in the ocean. The Stellwagen is special in that we have a lot of haddock, cod. We have a fish called a cusk eel that makes incredible sounds in burrows in darker environments. So higher latitude fish, we are, up in these more northern waters. And fish in these waters we heard a little bit in the movie about how light isn't our friend for very long distances underwater. And so if you go to places that are cold and darker, and then you pick out fish that are living particularly in those coldest and darkest places, you wind up unilaterally finding out that they're making sounds, and they're using sounds as one of their main ways of doing business, because light is even that much more not to their advantage.
Wow. And you've done studies of noise pollution in Stellwagen Bank, is that right? Can you just tell me a little bit about the studies and what you found?
Yes. So this has been a very special place to understand particularly the effects of shipping noise. And that is because we have a traffic separation scheme, one of those sort of lanes in the ocean that were talked about, that comes into the port of Boston directly through the sanctuary. We also have traffic that goes up and down our Massachusetts coastline through the Cape Cod Canal and going north. And then we have even greater bands of traffic further offshore into the deeper waters that go up and down the U.S. East Coast and in and out of New York City. First of all, we study those traffic patterns. We do a lot of data collection with the U.S. Coast Guard to know exactly what our constellation of traffic looks like. And we can do that at a 2-second resolution. So we're really gathering a lot of information about the vessels. Then we have these networks of recorders, and we can build that Firefly model that you saw in the film, where we can kind of see the acoustic footprints of this traffic moving around and changing over time. And we can quantify exactly what kinds of noise are coming from what contributors to the bands of sound, those frequencies, again, that whales are particularly using. So we study how whales are using the area, how fish are using the area, and then we try to better understand in the time periods and in the specific areas in the sanctuary that an animal really cares about, what does our acoustic footprint of human activities look like there?
And have there been changes made to the shipping through there or around there? And can you tell me a little bit about that? I promise people that if they came to this film, it wouldn't be depressing.
Yeah.
Right? Because there is a lot of good stuff happening in this area. So tell me a little bit about that.
Yes, we were successful in working with other federal partners in the Coast Guard. And colleagues in the National Marine Fisheries Service, also at NOAA, in shifting the traffic separation scheme. So those lanes in the ocean used to cut across a higher density area and of whale usage and feeding patterns. So as we come in the map, as you come around Cape Cod and you go straight into the port of Boston, if you do that in a straight line, we found you hit a sort of trough in the bank, in the Stellwagen bank, where the whales were not using that as persistently for feeding, because there was more sand and gravel habitat a little north and more sand and gravel habitat a little south. The lanes used to be wider and cut right across that sand and gravel habitat, and that's what supplies sand lance, which are the main feeding prey species for the humpbacks when they're here. And so shifting that traffic a little bit north and narrowing it did lengthen the time for ships coming in and out of the port of Boston a little bit, but through a lot of negotiations and discussion with them, that was made official and put on the books through the International Maritime Organization at the UN.
Great. And is that something that you see happening in other places, or is that like just the one success story, or are there like other good things happening in this area?
There are some good things happening in this area, for sure. When we started working on this issue, I think actually Brandon Southall in the film referred to going to a meeting in 2008 in Hamburg, Germany. When that was the year that we had our first meeting to invite a lot of people in the naval architecture and shipping industry to come together and really learn a great deal. And the U.S. put forward a proposal to the International Maritime Organization to form a group that would really look at, are there guidelines, are there things we can do to lower the amount of noise coming from commercial vessel traffic? And we got that proposal accepted, and we worked until 2014 until the body unilaterally agreed to put in place those guidelines, which at that point were voluntary. But it went from this being a we make sound issue to we have guidelines for exactly what to do technically to reduce the level of sound that's coming from ships. The next layer that is now in heavy discussion is whether those should be mandatory. And that happens at the same time that the shipping industry is taking on its first really heavy foray into control of greenhouse gas emissions. I mean, there's huge changes taking place in terms of fuel economy and fuel usage for the world's commercial traffic. And so them thinking about how to bring sound now into their mandatory architecture of making a greener ship is what's happening. And it's not a needle that everyone's happy hearing about moving on decadal basis, given the pace of what we have to do, but it's moving.
Interesting. I'm going to ask one more question. We'll open it up to audience questions. If people want to start putting questions up in the Slido, or is it Slido? There's been a lot of talk about the wind farms going up off the coast of Massachusetts, and concerns and negotiations about when the wind farms will be put in. And can you talk a little bit about that, about what the concerns are noise-wise as far as the whale migrations, and also is it just the installment of the turbines, or is there sort of once the wind farm is functioning, is there a sound issue then?
Yep. Okay. We know a lot more about the installation phase, and we're continuing to gather data about the operational phase. So the installation phase involves what's called pile driving, which is that we need to put the actual structures into the seabed that are going to hold up the wind turbines. And there's been a great deal of work about how to do that in the most environmentally safe way. And the first parts of that where a lot of negotiation has taken place is when to do it. There should be usually...
And the issues with whale migration, is that right?
Okay. Yes, right. So the issues with whale migration, but also with fishery sensitivities and spawning periods for fish and fishing. And so when and where are both really big things. But the siting process, the process by which folks think about where should the leases be, before anything ever gets to a company actually building something, takes in a lot of that. Where's the best place where we can get wind, but also is the most environmentally benign. And then on top of that, even if get to that sort of narrow band of where's the best place, now you have to work on, even then there could be some effects. So what do we have to do? We have to think about when is the best time to drive these piles. Mm-hmm. And it's definitely not when right whales are coming into our waters to feed on copepods and to nurse their young. And so you avoid their coming into the bay. So our major installation, many people know right now, is a large farm that's to be built 14 miles south of Martha's Vineyard called Vineyard Wind. And so there's been a lot of discussion about exactly how that project can be done the most safely, and a lot of proactive work done by the company with a lot of the same actual groups that are involved in making this film to come into our agency, NOAA, with a sort of front-loaded list of what it is that they can agree will be the mitigations they propose before they even go to being told by any regulatory agency, you should do this. They're saying, these are the things we'll propose. And that's because everybody sees the synergy, right? They see that if you're going to be looking for, for carbon reductions, and that's something you need to do environmentally, then you also have to figure out how to make that jive with some of your other environmental concerns. So that's a lot of the work.
Yeah, and I've heard conflicting information about whether or not the actual installed turbines make noise, because I've heard that they make a ton of noise, and then other people said, well, they don't actually make any noise. So what's what's the deal?
People still say both those things.
Okay.
So I didn't get at how you mitigate these things. So first of all, there are different ways to drive a pile, and they have different kinds. So the actual technology of how to get a pile into the seabed can have very different acoustic effects. And so you can also look to propose to use the most acoustically reduced method for driving the pile. On top of that, there are actual mechanical, you can use bubbles to your advantage this time, and not just their cavitation. You can create a wall of bubbles. And that wall of bubbles actually becomes a buffer to the sound going further from the piles. And so in that installation, they're working really hard on some pretty neat pile driving technology. Cool. And then on top of that, you can first you've chosen your best time to do the work, but then on top of that, you can't avoid the fact that there might still be whales around. And so you put in a lot of observation work from the surface and a lot of acoustic listening under the water that has the real-time capacity to tell you when a whale is calling, in what area, and to shut down operations and wait for whales to leave. So there's a lot of the sort of mitigation package that goes around the farm. So operationally, the best studies that have been done for the longest period of time have been in the North Sea, and that's because that's where we have some of the largest wind farms in the world that have been operating over the longest period of time. There are definitely some ecosystem effects of installing a large industrial facility. That said, the operational noise, it's definitely far and away different than the largest sounds that people are recording over the operational life of the wind farm right now are from the service vehicle vessel traffic that's coming back and forth and bringing people to do maintenance tasks and things like that. That has been the largest signature, greater than any vibrational sound that's coming from the operation of the things. But they also have a bunch of sensors, because one of the best ways to tell that something's wrong is if you start to hear a turbine. Yeah, just like it is with ships as well. One of the best ways to know that something's wrong with your propeller is it starts to hum.
That's interesting.
Yeah.
All right, good. All right, let's see what people ask. All right. Oh, we were hoping somebody would ask this question. Thank you, Erin. What can we do I'm supposed to read it on the iPad, but I forgot my glasses, so I might be able to read it. What can we do as individuals to reduce ocean noise? Voting, buying local? What would have the largest impact?
Those are two good ones. But buying local, because I work so much on shipping noise, that is something of just coming to a greater understanding of where the things that you depend on come from, and doing your absolute best to bring those decisions closer to home. So yes, reduced transport is a big part of this, and of course that crosses a lot of different environmental issues. So you get a lot of bang for your buck in making choices like that. Voting is important. I'll leave that there. And but no, a lot of the choices that are really important there. There are also a lot of just in general choices about how you run your home, and a lot of the things. I was saying this to Barbara earlier in terms of the more positive ways to look at coming to a new problem. When you learn about another environmental aspect that causes concern, and you think, oh, it's just adding to my list. I already had a list of the things I was worried about, and now I have a new one. The shorter list is usually what we can do personally, and we're usually cutting across a lot of these. And so that to me is the somewhat happier message, is the things you already knew about how you transport yourself, how you use energy in your home, how you purchase goods. All those things have just an additional benefit, you can put it that way, when you come to understand what the dynamics are of sound underwater.
All right, from Anonymous, somewhere out there. Is there acknowledgement from our government and or others in political power across the world of this issue? If so, what is the extent of support being offered?
Well, there is acknowledgement. And that support comes and goes. I mean, there was a very little support for this issue in Canada, and now there's an enormous amount of support for this issue in Canada. The United States brought the proposal to the first proposal to the International Maritime Organization to work on this issue with ships, for it as an example, in 2008, and Canada now is leading that effort at the IMO. So the leaders of the issue change, but the issue doesn't go away. And from an international colleague's perspective, we ensure that the stage is manned or womaned. But the leaders in the show do vary. I think that what has changed dramatically is that in a decade, it has reached a place where it's not going away at any of these stages. It's part of UN discussions about all ocean issues that come out of European efforts for good environmental status holistically for all EU countries, have noise as a main indicator. So there's widespread understanding that it's part of how we need to manage things underwater.
I was a little fuzzy on how where the movie left us with the Navy. Do they have more regulations now about how they use sonar and with regards to marine life?
They do, and it's. I think that what I would say is there was something that was said in the movie that I think was very honest, which is that they have become the largest funder of marine mammal research in the world. And I think it said maybe the world, and I would say in the world. And so this means that I have an enormous amount of colleagues that I've been working with for some time in the U.S. Navy to try to understand this issue. And the arguments that go on, and I think folks in the film talked about transitioning from research to actual mitigation and decision making. There is a lot more mitigation in place, but this film was actually part of an effort to change the optics away from the relatively small number of vessels that are using naval sonar, particularly some of the most politically sensitive naval sonars that a lot of discussion and press attention was paid to in the 90s. The really lowest frequency active sonars that are used by the U.S. Navy. There was a real sort of elephant in the room problem of all that growing attention to noise being focused on just naval sonars when the Navy had been studying this growing din of background noise from shipping that was doubling every decade, for now 50 years. So we've tried to change the dialogue to help people understand that there are different kinds of noise impacts that can happen really close to an animal, and that we mitigate those in some ways, and there are particular drivers of those effects. And then there are also these elephant in the room problems that are more critical and more omnipresent.
Yeah, it's interesting. All right. Oh, Miriam. Could that be Miriam Wasser, our environmental reporter, maybe? Does anthropomorphic sound impact smaller marine life like phytoplankton or crustaceans? Phytoplankton can't hear. Does it?
She's not wrong about she's not wrong about zooplankton. So in the last year of actually one of the biggest sort of issues in our community has been some initial research that seems to show that zooplankton, which are basically marine insect life, so crustaceans, are responding to sound, and in some air gun situations there might be some more massive die-offs So this was very preliminary work, but it has, folks across the oil and gas regulatory community, from companies themselves to government regulators to the scientists who are doing work for all of that, really heavily focused in the last year on that. And the reason for that, obviously, is that that's the bedrock of all of our ecosystem dynamics in the ocean, is the littlest stuff. And if the littlest stuff is being affected at a level that we didn't understand, then that will drive all kinds of cascades through the food system, through the food web. So there's a lot of focused attention on that, and that's really only in the last year that we've seen that taking place.
And crustaceans, bigger, like lobsters?
So lobsters and crabs, we've known for a while, are absolutely hearing. And the way they're hearing, so that's a whole different thing. You asked earlier if fish have ears. So some fish do have ears, but they perceive the sound pressure wave. A lot of the film uses sound and does this, and then everybody's like, okay, yes, it's a wave, got it, right? But actually, a large amount of marine life doesn't perceive the wave at all. They're absolutely detecting sound, but they're detecting it as the motion of particles in the ocean. So sound can be detected by marine critters in those two ways, and the mammals like us detect it as a pressure wave that is amplified by like a hearing structure, and in fish is really amplified if you happen to have what's called a swim bladder or a big air bladder inside your body. Not all fish do, but when you do, that basically acts like a hearing aid. Wow. So very large part, that's a lot of what a hearing aid does as well, is it does this massive amplification with a cavity of this wave. And that's what swim bladders in a lot of our swim bladder fish do. And they are therefore incredible hearers. And they can hear extraordinarily low sounds. Under ice, Arctic cod can just detect things forever. Really incredible hearing. But crustaceans detect that particle motion component. So lobsters and crabs are very responsive to sound. And we can even change the dynamics of whether you get barnacles and other kinds of critters on, fouling on a marine thing. You put a buoy down, you leave it there for a year, you got stuff all over it growing, right? Well, they've found that if you add a little bit of vibrationalness, sound, vibrational sort of acoustics to that buoy, you can actually change the dynamics of the fouling critters because they are detecting particular signals, and they're not foul. They don't foul on it if they don't attach to it. They're using sound as a settlement cue.
That's amazing. Huh. All right, Bob. How do whales handle storms? It must be louder than ships. Is it something about the frequencies of the engines that's more disruptive? That's an interesting
Good question.
Thank you, Bob. Interesting.
Yeah. That right in that question is the dynamics of all of the understanding of how we do assessments of the impacts of sounds. Is why are some more impactful than others? Is it because one's louder than the other? Is it because it has different frequencies, tones, and why would that matter? Well, first of all, if you're lower frequency, it goes farther, and if it's higher frequency, it's more local. The sound energy dissipates more quickly. So in this case with storms take place, and during a storm event, they can absolutely dominate everything going on acoustically under the water for the period of time that they're on. The thing with ships is that they're omnipresent. They're never not there, and they produce their strongest cavitational signal from the bursted bubbles takes place at around 50 hertz. 50 hertz is right at the bottom of all those of us who are still have pretty solid hearing, right? And it's already pretty low. Like those blue whales and fin whales are calling and listening below that even. And so in the 20 hertz to 50 hertz band, that's where that bubble burst is really, really making a loud hum. And those waves can again travel the way they showed you in the film. So they can travel over enormous distances without losing energy. So they contribute to each other, and that's what makes that background noise, that background ambient sound noise. It's that lack of dissipation of that constellation of ships over an ocean basin. So, so when I listen off the coast of Massachusetts in relatively shallow water, into the mouth of Massachusetts Bay, I'm listening to the traffic of Massachusetts Bay, as well as the ship that just passed right over my head. It's loud. It goes like a car passing you on the highway. But your other experience, if you live near the highway, is that you're never not listening to cars, right? It's that combination that is different than storm events, and it's different different, therefore, than what animals have evolved to cope with in terms of levels of background sound exposure.
All right. Anonymous, how did you go about getting into the work you do today?
Well, there's lots of different ways. You know, my path, like everybody's, is really idiosyncratic, and gets you, yeah, it's very much my path. But there are a lot of different ways, and I talk to students about this all the time. And we have a large fleet of graduate students and postdocs who work in the Boston area on this issue, and they all have their paths as well. But for me, what it's entailed is growing up on a farm with a musician as a father.
It all came together.
Yeah.
That's funny.
So those things came together, and the person you saw in the film, Christopher Clark, was my neighbor. So those things all wound together pretty early on for me to encourage me to do what I do. But since that time, there are a variety of programs that have been really important and that continuing to be very important for undergraduates, for graduate students, for people who want to pursue this kind of science and policy making. And those are, anyway,
Are you a musician?
I am. I'm a singer.
Oh, I didn't know that. Do you feel like that your scientific work influences your music?
Absolutely. Yes, I mean, I don't do music the way maybe others in the audience might. I'm not a somebody who's in a recording studio or anything. But I've spent a lot of my time singing in bands and singing in general. And I think in general, if you just being somebody who hears a lot and spends a lot of time listening, and that is actually the answer to the question of how did Sting get involved in this film. He really is somebody who's environmentally quite active, but somebody who, just like he says, became increasingly conscious of hearing. And I find that as I talk to people, there's just levels of that consciousness that's constantly emerging for us, right, about hearing. And, the people we know who are hearing impaired have that because they have it through loss. And there are also people who are visually impaired who have it through accentuation. I know people who don't see as well, and their understanding of hearing is just phenomenal. I mean, it's just an amazing, amazing, amazing thing. So I think that, there are lots of different experiences that change the way you understand hearing.
All right, they're giving us one last question here from Anonymous. The fossil fuel industry is responsible for much noise pollution, but what about alternatives like offshore wind farms where the Atlantic right whales live? We talked about that. But is there anything else you want to add on that about the wind farms? Anything we didn't touch on?
Well, no. I mean, I think that it's. I guess I would just circle back to this: is the film was made and has been being screened all over the world. But you did it's fun to talk about it sometimes in Boston because you saw a lot of touch points to Boston. And this is a place that these animals live. Shipping is a part of the fabric. We're very much part of the urban corridor, but we're also a state that is trying to advance these alternatives. And so we're sorting it out a lot right off the coast of your state. And I would just encourage you to continue to be active and watchful of those things, because that really is how energy comes into your home and your local choices. You can put pressure on companies to be as environmentally sensitive as they can be through the dollars that you spend. So this is a very local dynamic for us.
Great. Super. Thanks, everybody. Thank Leila Hatch for coming. Thank you. Thanks very much. And before you leave, Amy's supposed to come up, right? I remembered. Wait, this is Amy McDonald, who runs this place.
On the way out, we have a little kiosk, and if we don't have your email, please sign up. We'll send you newsletters. We'll let you know what's happening in this space coming up. You'll be the first to hear. Thank you for coming.
Thank you all very much for coming. Thank you, Leila.
In the court, because the Supreme Court at least has gotten so conservative. So demand